Hi guys, long time no see, no? So welcome to Tariga Engineering Video Tutorials. Again, I'm Engineer Ronnie T. Tariga II, and welcome to my YouTube channel. Okay, so I'm sorry I was not able to post this video sooner because I have some personal matters that needed to attend, no? And syempre because of the crisis that we are on today. Okay. So just look at your screen on how to like a video, how to subscribe, and how to get all the notifications that is coming for the next videos that I be posting. No? Okay, so without any further ado, let's discuss a topic that is actually, present siya sa lahat ng mga engineering, no? Kasi this is a general engineering subject, and then this is very important, no? And that is called the engineering mechanics. Dalawa yan, statics and dynamics. And we'll be discussing the dynamics only. Okay. So sa dynamics, there are two categories or branches that being considered. Okay. And that is the kinematics and the other one is the kinetics. Okay. Yung kinematics is the study of dynamics that talks about the geometrical analysis of a motion. Kumbaga, kagaya ng rectilinear motion, linear yung motion. Projectile, yung motion yan is parabolic. Yung circular motion, circular yung motion. So this is a study that talks about the geometrical analysis, no, of a motion. Yung kinetics naman is analyzing the forces that causes the motion. Diyan mo makikita yung mga frictional resistance, mga centrifugal forces, gano'n, no? Reverse effective force, yan. Okay? But in this video, we need to discuss first, syempre, yung kinematics. Okay? So sa kinematics, we will proceed first to rectilinear motion. Okay, as what I've told you before, rectilinear motion is a linear continuous motion. Okay, so suppose we have a car that is merong initial velocity that is headed in this direction at a acceleration A. Okay, so as it goes by, meron siyang change in position from point 1 to point 2. And yung S, this is called the displacement. Okay, displacement. And as you put this car here, nandito na siya, there is a final velocity that is not equal to initial velocity, of course. Magiging equal lang sila if that is a constant speed. Kasi kapag sinabing constant speed, that should be acceleration is equal to 0. So yan yung mga ginagamit natin sa motion problem sa algebra, which is madali tayong mag-create ng mga relationship. Okay. So ngayon, we'll be discussing first the formulas that are necessary for rectilinear motion. Okay. So sa rectilinear motion, dito tayo minsan na nababother, no? Kasi meron siyang constant acceleration and meron ding variable acceleration. Okay, later I will explain what's the difference between them. Okay, so let's derive first the fundamental formulas that are used in dynamics. Okay, so syempre, velocity denoted as V is defined as the change in this position over a change in time. So if you will do that in calculus, that is the ds over dt. Okay, ds over dt. Kasi differential means change. Okay? And meron din namang acceleration. Acceleration is defined as the change of velocity at a certain period of time. So rate of change of a velocity in a certain period of time. Okay, so that would be delta V over delta T, change in velocity over change in time, which is, ganito, if you will differentiate, velocity is equal to ds over dt. Okay, and if you will differentiate that again, having the second derivative, you can get the acceleration. Yes, you heard that right, no? The second derivative of a distance function is equal to acceleration. Okay? So, yan lang naman, no? Second derivative and first derivative yung velocity. Okay. So, we have now a relationship that is V is equal to ds over dt and A is equal to dV over dt. If you will rearrange that one, we can get dt equals ds over V and dt is dV over A. Okay. By equating both dt there, you can get a relationship that is ganyan. Okay. ADS is equal to VDV and that is the differential relationship between acceleration, displacement, and velocity. Okay, so anyway, these formulas, ito yung ginagamit sa variable acceleration. Kasi bakit variable? Meaning, kapag sinabing variable, wala siyang absolute na ano ba yan? Value, no? Kasi yung variable, it changes from time to time. Okay, so anyway, these are the basic fundamental formulas that are used in dynamics. Okay, now, this is for variable acceleration. Now, for constant acceleration, we will derive formulas that are being used here. Kapag sinabing constant acceleration, the acceleration from point 1 to point 2 would be the same. Okay, constant siya from point 1 to point 2. Okay, so if you can remember, that is meron siyang tatlong formulas, no, that are being used in this principle. Okay, we need to derive that one kasi para alam natin saan siya nanggaling and at least ma-appreciate ninyo ano yung root of this dynamics na subject, okay, or topic. Alright, so let's start deriving. Okay, so anyway, meron kayong makikita mga integral dito but I think you will appreciate this one, no? Okay, so from the principle A is equal to dV over dt, if you will cross multiply that one, you can get dV is equal to A dt. Okay, and integrating both sides, you can get that one. Alright, syempre, you will integrate both sides, differential yan. Okay, supposing that yung velocity is nag-start siya from initial velocity and it will end to final velocity. Where sa integral, this is a definite integral having an upper limit and a lower limit. Okay. So syempre, usually if kailan tayo mag-measure ng initial velocity, that would be the time 0, suppose, no? And it will end at time t. Okay. So if you will continue that one, you can have that, no? I-copy ko lang. And syempre, you can factor out acceleration because that is a constant value. Sabi nga dyan sa itaas. Okay? And now, let's integrate. Okay, di ba? Integral of dV is equal to V. And it approaches from VF to VO. Okay, di ba? Kapag ganitong principle, you will just have the upper limit minus lower limit. Same as dito, integral of dt is equal to t, that would be approaching t at saka 0. So upper limit minus lower limit. Well then, if you will simplify that one, you can have upper limit minus lower limit. Parang i-substitute lang talaga yung VF at saka VO. Okay? And A is equal to T minus 0. Kasi dyan. That's why you can have a formula that is familiar to you, that one. Okay? So that would be our first constant acceleration formula. Please take note of that. Another one. The next formula is based on velocity is equal to ds over dt. Okay, again, cross multiply, you can have that one. And integrating both sides, you can say that one. Okay, let's put some limits. Syempre, integral of dt, again, from 0 to time, no? 0 to t. And if kailan ka nagsimulang mag-count sa time, that would be the time na magkuha ka rin ng distance. From 0, supposing it will end sa s. Okay? So, now, itong velocity, constant yan, no? Constant because syempre, that is a velocity. Ang integral natin is varying sa time, not velocity. Okay? Say, take velocity is equal to final velocity, no? So, we will substitute V as VF. And now, as you can remember, as we derived kanina, that is VF is equal to VO plus 80. By substituting this VF function there sa itaas, you can have that one. Okay? And just distribute the integral part to this binomial function, no? So integrate VO dt plus integral of AT dt, and you will have that one. Okay, so parang i-distribute lang. Okay, then continue integrating. So say that is ganyan. Alright, so pinalabas natin ulit yung mga constant. If you will continue, you will have that one. The integral of ds is s as it approaches from 0 to s is equal to VO times integral of dt, that would be t, from 0 to t. Okay, plus. Okay, so as you remember sa integral, this is yung tinatawag nating power rule. Integral of t dt is equal to the integral of u raised to n plus 1 all over n plus 1. So that's why t squared over 2. Okay, and approaching 0 to t. And that's why you can have a formula. Gi-substitute lang natin, upper limit minus lower limit. Okay, and that's it, no? The distance is equal to VOT plus 1/2 AT squared. That would be our second formula for constant acceleration. Okay, so that's it. We have one more to go, no, para makumpleto yung constant acceleration ng mga formulas. I know you're familiar with this, no? So anyway, you don't need to know this one, but pinakita ko lang siya para at least ma-appreciate nyo saan siya galing, no? And if malimutan nyo man to, at least hindi kayo mawawala. Okay? So the last formula is syempre from the differential relationship of a motion. So integrating both sides, that would be that one. Continue. So integral of ds, that would be from 0 to s, and yung dV naman from VO to final velocity. Okay, so if you continue that one, you can get that. Integral of ds is s, integral of v dv is v squared over 2. So if you substitute upper limit minus lower limit, you can have that one. And simplifying, that's why you can have the formula, which is Vf squared is equal to Vo squared plus 2As. And yes, no, nakompleto na natin yung constant acceleration formulas. Okay, let's do some recap. No? Okay, so these three are the basic fundamental formulas of constant acceleration. Again, you can only use these for constant acceleration problems sa dynamics. Okay, so ano ba yung mga sila? Okay, so Vf is equal, or that is the velocity after t time, or minsan tinatawag natin yung final velocity, or the velocity after a time interval t. Okay, ganyan yan. And VO is the initial velocity, velocity where you start measuring the motion. Okay, T is syempre the time interval or time traveled. S is the displacement of a particle after certain time t. Okay, and A is the constant acceleration. For constant acceleration, if that is positive, that is called acceleration. And if that is negative, that is called a deceleration. Okay, no? So, ang acceleration from, suppose ganito, from at rest, tumakbo siya. So, it accelerates from 0 at naging something na velocity. Yung deceleration naman from baliktad, no? From it is traveling at a certain velocity, and if want to stop, pa-decelerate. No? Kumbaga parang mag-brake ba, no? Okay, sana all. Okay, so gi-brake kanya. Alright, so anyway, this is for the constant acceleration. I repeat, no, for variable acceleration, yung na-derive natin kanina, that would be the 3 of this formula. Okay, V is equal to ds over dt, or A is equal to dv over dt, or A is the second derivative of the distance function. Okay, and the other differential relationship, those are the formulas. Okay, so ito yung mga basic na mga formulas. Alright, so I will cut this video na lang to this. And we will have our sample video of sample problem for the next video. Thank you.